Our next speaker is Manuel from Illustreets. He'll be talking about how he built enterprise maps with Meteor. Let's welcome Manuel.
Good evening, everyone. I'm Manuel, and I'm the product architect of Illustreets. So it happens that I have quite big boots to fill here after the first two speakers. So if I start stuttering, it's not the cold, it's the boots. Many moons ago, we created and launched Illustreets, which at that time was a geospatial application that took a ton of data, governmental data. It was all about open data at the time and now as well. And we've put it on a map that was very easy to use and still very easy to use. And that was the ambition. It's still online today. You can see it at illustreets.co.uk. Then, as a result of this very advanced prototype of geospatial application that we launched and we built with Meteor, we started with Meteor 0.43, which is quite early, quite brave at the time. We started working with some of them quite high-profile clients. And it was a leitmotif in all the discussions and all the requirements that I would gather. And that was, it's just Illustreets is perfect. I just want it with my data or with just slight modifications. And we get on projects that used to take months, obviously, because inevitably you get to rewrite code in different ways. And at some point we said, hold on, we can do this better. How about we write it as a SaaS, even braver than just SaaS where you don't have to write code to create geospatial apps. And together with Michael Klein, we call him the German engineering machine on our team, we and the two other amazing partners that we have with respect to business and strategy and commercial, and a lot of amazing feedback from our clients, we set on to build Illustreets 2.0, which is not just an app that you put out there with data, is an app that lets you build apps, geospatial apps. Not in the way that, say, Meteor Kitchen, if you're familiar with it, does. It's just in more of a very visual way, and you then we'll see in a minute what it does. In no small part, Meteor has been has contributed to our project. Actually, it's been essential with respect to development time, because we just got a lot of things like that in the stack itself, but also with the documentation that's available in the community. And well, we're going to be launching very soon, and we also have several clients that we're working with, and we have a huge backlog of amazing features that we want to add, and we're looking forward to implementing them. Now, I would like to show you what we're talking about, and that is Illustreets is about to launch soon. We're quite pleased and thrilled to be at Meteor HQ and talk about this. And so this is the first public preview of it. This would be the interface where the apps that you create and a publisher creates in the back end will be displayed. They can have description, you can have a screenshot or whatever layers you choose. And let's go. This is an app that I've built in actually less than 2 hours, particularly for this presentation. And Illustreets is quite beefy SaaS. It uses several services at the back. We call them small enough services, not microservices, because they're not. They're quite fat. One for creating and serving the tiles. Then on top of that, we have a caching service, which does in-memory and on-disk caching, because tiles is quite a processor-intensive work. Then we also have a database that has a gatekeeper in front of it, because you want to communicate with it through an easy-to-use API, even if it's in backend. There are a couple of Python services that we use as well, so it's a pretty complex app at the backend. The front end, when we get here, so these are the tiles that are produced by all this big infrastructure at the back. And this is created from a data set that you simply, if you're familiar with geospatial data, just a shapefile you upload, and based on the data that you have in the columns, you can style those layers. Then you can, later I'm sure you can create reports, widgets, and all sorts of things. Here, a user, this is the interface that a publisher would use on Illustreets, or a manager, an admin. And these are layer groups, for instance. What you see, they're colorful in the menu are layer groups. Within here, you have several layers that you can toggle on or off. These, for instance, are schools from an open data set by the Department for Education. Then, within each layer, you can enable filters that the app will build for you depending on all sorts of statistics that we calculate for each column in that particular data set. Min, max, we pre-fill this filters. You don't have to do anything to get this type of filter. So say if we want to, if a user playing with these layers in the front end wants to filter the schools by a particular local authority, all they have to do is tick that box, and there you have it, Barking and Dagenham schools. They're there for you to see. You can even quickly feed them into the window for better view. You can reset the filters then afterwards. It's all made to feel very natural, to make it very easy to explore data, even by non-technical users. Of course, you see this is quite a rich interface. That's the interface that the publisher sees. Here you create layers from a data set, or you clone them. You can create layer groups within which you then drag and drop the layers themselves. You can set a base map of the actual app that holds the layers. You can style the layers, set what columns, what filters the users can have in the front end, like this ones. These three have been set in the back end here. So here's where you toggle the filters for that particular layer. You could set interaction. So typically mapping applications have, and I think whoever's seen a mapping application, the most familiar one would be Google Maps, uses info windows. And that's all the interaction you get from a map. Well, we got the people used to reports that pop up with charts are easy to understand and read. So here you set up a layer interaction, like info windows in these reports. You also have settings for title, description, and I don't know, column aliases, all sorts of things that would be useful to your everyday mapping reports maker. And just quickly to highlight how important it is to have a good, how telling it is to actually be layering data on maps. So imagine these are the postcodes. Sorry, this is my fault. I forgot to mention these are the London postcode districts, styled by how expensive they are by the house prices in 2016. But say if you want to look what postcodes are most at risk of floods, you just simply overlay the flood zone. You might notice that there's a slight lag. That's because this demo server is based in London, so it has a bit of latency. It doesn't have a CDN in front of it, the particular demo server. And you just overlay it, and you see what's at risk. But then on top of that, imagine you can overlay everything, addresses, properties. You can see if you have a list of incidents, insurance incidents, how many properties have been affected by floods. So you can do all that in an instant without coding. And then you create this app. I'll show you later. You have a very sophisticated mechanism for sharing with user groups and roles, and then just split and send those apps to those particular users. Now, since we're here, I would like to quickly, I will alternate between showcasing the app and showing a few tips, and some of them might seem outrageous. I'm not here to teach anybody to code. There are a lot better people here than me. But we discovered a few things, particularly when you're working with maps. It's a different way of working and thinking. So about session variables, everyone says they're evil, just like they used to say about eval. But if you're set to create a templating library for JavaScript, you'll have to use eval. You can't not use it. So you can't say it's evil. It's evil if it's used, in a bad way, like reading JSON. You can use parse for that. So I think, we personally think that Illustreets session variables are not evil, they're just misused. So imagine you create a large application. We built an application that we started in like a package sort of architecture, packages, the way, if you're familiar with Telescope, that's what it is. And we ended up with a 54 package sort of application, pretty large. And on top of it, we have the modules, what we call this ECMA 6 is the latest standards. So we go with packages and modules. So imagine you have several modules. One of them, that map that you've seen there, is it's a reactive beauty. It just sits there and waits for commands and messages from the map search package, or from the layer package, or from the, you'll see there's the drawing, we have a drawing library, quite a complex one as well. And it waits for information from all those vector layers, tiling, image layers that have to be overlaid on the map, searches, markers. How would you transfer that information from several packages, which in production in certain instances you might not install even? So you have to have a way. So the way we use session variables, like a very, very good and what's reactive by its very definition, a mediator pattern. So we scope it really well. Is a particular a package waits for a particular session variable, then we scope it by the name of the package, the component within that package that needs it, and by the name of variable. And we control that very efficiently. We're trying to, only for inter-package, inter-module communication. If we're inside the package, we just use a local reactive var that we export and between 2 or 3 files. It wouldn't work to export a local reactive var between packages, because if you want to not, say, deploy one module or one package, then it's going to throw errors. What you go and comment out the imports? You can't. So session variable works really well for that. What we found is this little beautiful gem that Meteor has, which is the Connect API that's exposed through Connect handlers. So imagine anything that you can do in Node with Connect, or with Express for that matter. In our case, it was really important to have a super fast authentication proxy for tiles. Imagine when you open that map, 24 tiles are going to be requested from the server. We have to cache the user objects in memory and then quickly use login tokens or several different other methods to authenticate those tiles. And we do that with an authentication proxy, which seriously, even in development where it's a bit slower, adds only 2, 3, say maximum 4, I've seen, milliseconds per tile. We're pretty happy about it. Now that we, I talked about these two tips or lessons learned, I would like to go to another interesting part of Illustreets, which is displaying the data that's not only on the map, but in the actual charts. There are two parts really important with mapping: the data on the map and the data they get, say, from within the map. So, since we're at this house prices in London, the way Illustreets.co.uk is like that. You click on the map, you have a split screen report that appears, and it has charts created. It was all hard-coded with the information from the particular data set. So now, you click on this. It will get you the information about, these are two charts, two sample charts, just showing you the evolution of prices. And that here is not dummy data, that's actual average prices. It includes apartments and homes, houses, as the evolution of prices between 2010 and 2016, and then the volume of transactions. And ever since Brexit, Trump, and all the rest of it, the transactions have gone the way of the dodo, almost. This is again the administrative interface. Each chart has a pretty sophisticated GUI where you go set the type of chart, colors. This is a query builder. Choose what data goes into it. This alone, the widget builder for the charts, will take me easily 10-15 minutes to show around. So, because there's a lot to talk about, I'm going to just quickly glance over it. The way these reports work is pretty smart, and you have the way you add these pages. So imagine in a geospatial data set, you go either by what intersects the particular point I clicked on or I searched for, or what feature we're talking about is a particular polygon, and then you can talk about the other spatial data being related to it. Within, overlapping, these are particular operations in geospatial. Oh, by the way, this is not done in Mongo. This is all PostGIS. Meteor communicates with PostGIS for this, and we'll tell you about some tips after this. Let's switch to the preview mode, which is basically what the front-end user will see. And we have here a dedicated page, which is from data within this particular layer that we're looking at. And we have what we like to call a cross-layer report, which basically, based on the point that you clicked on, it goes on other layers that we've seen earlier in the map. I'm going to quickly go there so this is a report for schools and amenities. So within this app here, we have some private layers, some points which we keep, and look, these were the schools. I'll put them on. So let's go again and click. Yeah, we're going to we put CDNs in front of them in production. So if we look at the close layer report sample, it's going to look around and count within 1 mile. This is, when it says by rank, this is by the education inspectors. By rank 2, there are about 4 schools, and rank 1, 5 schools, just around this particular point that we clicked on. Of course, you can go to actually show which schools are those. The widget, we have several widget types in the works. The table one, you simply show the schools and the distance from that point. Here is a count of food amenities. This is a completely private layer. You don't see it on the map. It just statistically works, counts all the takeaways, restaurants. And within the same interface, you set everything. You set the radius for search, then what type of aggregation, what data you want to bring in. And all that, I repeat, this whole application, you could easily create an app that's 7, 8, 9, 10 layers. If you know your data, and you know what you want to present with it, it'll take you between 1 hour and 2 hours to create all of it. Now, I will show you, so whilst you're here, and you have this other layer with the schools, what happens if I click on one of these? I would actually like to go into the preview mode, because it's a bit more interesting. So, click on schools, you can set, this is something that you totally set, as a quick preview, a pop-up, what every other GIS application shows you. You have here the data. You click to see the report, and it takes you there. And so here's an example of, you'll notice the median house prices. We have another layer with about 1 million points that represent the transactions in the last year. This simple chart here that you see is set to look around within half a mile, take the median price of all of those transactions, split it by what we call in England is freehold, as in is a home, as in it also owns the land beneath, and leasehold, which typically is an apartment. It means it doesn't hold it doesn't own the land. So you quickly take that information. If we click on a different school, so around this school within 1 mile is 1,800,000, not the cheapest, I'll say. And here, all of a sudden, the freehold is 1,600,000. So it's obviously in the chart, but I couldn't be bothered when I quickly went over it. You can go and sort it. So it actually orders the data consistently, either by count or by name or by the label of the chart. And here, for instance, a comparison of school capacity and number of pupils versus, I'm just being told that my time is running out. So quickly go over small enough services architecture, at least in our case, because we built in Node.js, but also build in Python, Java. We have C services like say an importer that we use for the database. So we go by small enough services architecture, and you start from modules, then you can pull cohesive modules and create its own service. It works really well. And we also found the power, since we're talking about charts, you save configuration, but you pull data that might look differently is the same data, but it looks different in charts, looks and a bit different in tables. What do you do instead of recreating those objects over and over again, or a new collection? You simply transform the collection a little bit as it comes on its way down. The admin interface, I'm afraid there's no much time for it. It's basically, it's the boring bit where is the ugly. That's what we call the ugly. As in where you see all the data sets, where you manage the users, the user groups, where you add new users, replace them, give them publishing rights. Just a quick, this is what the data sets look like. You upload these. You can upload 10 at the same time if you wish. This is going to work. The importer is a separate service, split as works as a cluster. It does. It takes your data, munches it, and gives it to you to make layers. Very quickly switch here. This is the type of architecture that we use. We used to use with the packages. We also applied in the new with the ECMAS 6 modules. We like to think in terms of modules with components inside. So if my drawing library is a module, within it, I might have a HTML file, another JavaScript, another HTML, another JavaScript. And that works really well. There's very little time to. I would like to give. This is a shout out, which are more than deserved. Some of the places where we learned and some of the packages we use. Although you might see dead or abandoned software there, it still helped us. We patched it. We're going about. It's very good software, very well written. You read it to understand how it works. You put it there. It will stay with you for as long as you want it. And two important lessons. One, I am absolutely certain you can't build a serious product on your own. You have partners and you have clients and you have to talk to them all the time. Second, don't do DevOps with JS code. Forget about Node.js clustering and the rest. Use Galaxy or get your hands dirty with Bash scripts, Ansible. We have time for one question?
Yes, we definitely have time for one question. But I just wanted to say that looks really impressive, and you only clicked around on a few things, but I could really see how much more there is behind it.
It's about 5 minutes of, it's like 10 minutes of condensed.
Right, questions?
What's the pricing model?
What is the?
How do you guys make money with it? Was a pricing model?
Well, that's an example. Actually, there are loads of companies in everything that you look around is geospatial. Constructions, tunneling, oil extractions, schools, buildings, and they wouldn't build them when you don't have population that needs those schools. Train stations, everything. You'd be amazed how much geospatial is around. It's a market that when we last looked, only data, not geospatial, data market as data products was 8 trillion calculated. That's an insane amount. And there's not enough software for it. And we're working with clients that want it today or they wanted it yesterday. They'll deploy this and they sell their data or communicate it to their stakeholders. There's a tunneling consultancy in Australia. They want to communicate with the stakeholders where the tunneling is going, will the schools be affected, what the local authority. Imagine when you have to communicate geospatial data to about 8 different stakeholders. That fits in there it's perfect. No, it's the guy who's making the map. Because the guy using the map, we try and we've done our best to create a very, very good UX for their users. So if our clients' users are happy, our clients happy, we're happy.
Everyone's happy.
Yes.